Hi everybody. So now we can already download a audio file, transform it to WAV file and apply Whisper to get the text or the transcript. But we still have the problem if we have multiple speakers that we cannot distinguish between who said what. And for that we want to make use of another Python package, again very awesome, and that this is public and open source. It's called Pyannote. It's pronounced apparently somewhat French. I'm pretty bad in French pronunciation, so not fully sure how it is correctly, but it's not Pyannote, how I used to say. Okay, so what's the deal here? You can see here the GitHub page, and then already a code snippet. Let's look a bit into the model. So there's this blog post here, one of those, one speaker segmentation model. So let's use that to give you a bit of a introduction to the model. So kind of what you can see here is over time we record whether speaker 1 or 2, like here it's 90 or 91, is speaking. So like at the beginning no one is speaking at all, and then there's shortly speaker 1, and then also there's sometimes a quick overlap. And I think like that's basically the supervised learning data. So that's kind of how it really is based on what humans say it is. And now we need to basically see how we can get something like that from the model. Okay, so what you can do is you can kind of just take one excerpt here, that's the wave format plot, and then on this short sequence you basically now get, if you apply inference from the model, you kind of get for 3 different speakers in this case, so the green one, the orange one and the blue one, you get kind of a likelihood whether that speaker is speaking. So in the beginning you have a likelihood of 1 that the orange guy is speaking, and then it seems to flip and the blue guy is speaking. But you also can see like the orange doesn't fully decay to 0 but still is somewhat elevated, which kind of, if we binarize it, so kind of everything above a certain cutoff, which might be 0.5 here. So whenever the line is above 0.5, we classify it as this guy is speaking. So here is like kind of the first one, and then not sure whether there's a tiny gap, but then kind of the other one is speaking, but also again this guy also. Okay, and so we have an overlap in speakers here. Okay, so what the model does is actually splits up the full audio into short excerpts, and they here by default have, I think, 5 seconds, and kind of the next 5-second interval is 2.5 seconds further. So you kind of have an overlap, and on these kind of 5-second intervals you always check kind of this inference of whether kind of which speaker is speaking. Okay, but by that you still don't have like a global result, who is speaking when. And but based on these like snippets, so to speak, you can get different how should I put it, like different results, or depending on the question that you are kind of trying to answer. So for example, you can answer the question, is someone or is anyone speaking? So obviously you just need to look whether there is any one line which is significantly above 0, and you do that on the individual snippets, and then there's an easy way how you kind of combine it. It's basically you just need to take the maximum function of it. Sorry. Okay, so like, is someone at all speaking? If you kind of combine it, then you get this outcome. You can binarize it, so at a certain cutoff or onset, so everything above 0.5, we say, well, there was someone speaking, and here's kind of to verify that's the true labeled data. Then you also can look at whether there is some overlap in speaking. So for example, here or here. So you get kind of likelihood function, so to speak, whether there are overlaps or not. And you can again binarize it. You also could you can check whether someone is speaking and is it more than one, so overlaps. But you can also just try to count generally the number of people speaking. And you also can try to find out whenever the speaker seems to switch, which kind of you get multiple spikes here. I assume you might get a problem with this overlap, but yeah, not sure. Never really used it. Okay, but in the end, the segmentation model itself kind of just applies this inference on these 5-second snippets. And if you look at it, you kind of don't get a global recognition of speakers yet. For example, in this interval, so 15 to 20 seconds, this is this one, and the next one. So basically here, the orange guy is speaking, and then it switches to the blue guy. And in this model, kind of, the speaker who is actually speaking here is again denoted as an orange one. So it doesn't have global knowledge, kind of, whether this speaker and this speaker here are the same. It just knows here there are 3 different speakers, and within that sample I can kind of distinguish them. Here within that sample also, but you cannot draw the connection between both. To do that, you kind of need to apply another layer kind of on the global inference result. So what you kind of probably do in the background, but I mean I'm really not familiar with the package at all. So usually you have you try to represent certain things in an embedding space. So kind of if you have an image, you want to represent the image as a vector of numbers, because eventually your model will need numbers. And kind of, let's say you represent it in a 600 dimensional space, so basically a column vector of 600 entries, then you can call this vector representation of your input, you can call it an embedding. Why is it not just a vector? Because hopefully it also comes with certain nice properties that basically images that are rather similar, they hopefully also end up rather closely together in the embedding space, or at least pointing in the same direction. Or actually with language models, where you also a sentence or a word will eventually get mapped also to an embedding, like a 600 dimensional vector. You sometimes get even smart arithmetic on that vector space. So not only words that more or less mean the same, they point in the same direction, or the points are close to each other, but also if you subtract from king, the vector king, the vector man, then you get kind of what's the difference between king and man? Well, it's basically being royal or not. So if you apply that difference to queen, then you also end up kind of at women. So you have really sometimes a lot of meaning on these embeddings. Okay, and I assume kind of here each speaker is represented somehow as an embedding, and probably in every slice. So always looking obviously somewhat different, because kind of if you just create an embedding on this slice and an embedding here, then there's no reason why they kind of should be exactly the same. But eventually you kind of could identify that basically the orange speech here sounds pretty similar to the blue speech here, and by that you kind of can draw the conclusion that actually this is the same as here the blue line, and eventually find out who is speaking on a global level. Hope that makes sense, and hopefully I'm not telling anything wrong. Okay, so how can we use the model? So the Pyannote audio model. So one thing is you can use the pre-trained model. So you basically download the model and then you can do this slicing yourself. But you also can directly apply a pipeline which solves like this global speaker problem for you. So here we kind of from Huggingface, let's see where we do it. So I think where's the model? I kind of don't. Here's the pipeline. So basically from Pyannote Audio you have this pipeline. The pipeline gets a pre-trained model. It's not a segmentation model anymore. So I think segmentation would be more or less this kind of task here, but it's a speaker diarization model. And once you have the pipeline, it's pretty straightforward to apply it. You just apply it here to a audio file, and then you get basically this so diarization output, which is kind of a table that tells you in which time interval is which speaker. Okay, and you could then visualize it also with that chart, which is like either table or chart. So that's exactly what we want to have. It's the missing component, so to speak, to our Whisper model. One more remark, to get the model, you need to provide a authentication token. So the model is still for free, we can use it. The creator or maintainer of that model just mentions that it would be nice to get a feeling about how many people are using his model and also for which purpose. And that's, I think, very valid for the fact that he really provides this awesome model open source. So what you just need to do is you need to provide a Huggingface token. So you need to, in Huggingface, you go to your, not your profile, but settings, exactly. And then you can go to access tokens. Then you can create a token. And I think somewhere also we need to answer certain questions, because kind of what is the intended use that we have for this? I don't know, I filled it out some days ago. Also there's the space on Huggingface, so that's about the embedding. I don't think we need it right now, because if we just apply the pipeline, we get more or less everything for free, so we get globally who is talking, more or less. But if you want to, like globally within one audio file, we get it. But if you want to do this somewhat across audio files, so we have one podcast show with multiple episodes and always the same host. So then obviously if you want to kind of make sure that speaker 0 here and speaker 0 in the next audio file is kind of the same person really, then we would need to have the embeddings. So there seems to be also an embedding framework from this Pyannote, which we could use. And here then you can see basically you need to fill that out. And with your Huggingface account probably, and your token is also connected to Huggingface, so then it should work. Okay, that's it for now. And next step will be to apply that model and then kind of match Whisper and Pyannote together to get a nice diarization. Alright, see you.